texting a lot of people.
They're coming. Lily has done me a solid and not come today because Cole. Lily's little cousin has hand, foot, and mouth. The baby has hand. That's like a viral thing.
I hope so.
And I don't want it. And I suppose y'all saw my email about, please don't be around me when you're sick. I really don't want to spend my whole winter sick or however long I have to deal with this.
That's
so
why I choose not to get sick beforehand.
Thank you, Kai. We're like this.
Oh, yeah.
So anyway, so Lily is staying home because she doesn't want me to be sick with something terrible.
Miss Danny, can you adopt me?
Sure. I think I'd have to fight your mother. She'd probably win. She's tougher than me. She probably doesn't want Kai.
Yeah.
Save it.
Why? We're basically already brother and sister already.
Ethan made me blondies. I'm eating them. They're good. What?
Actually, good parts and actually bad parts.
Ooh, I mean, Dylan, good job on this.
What did I do?
Caramely.
I actually, like, if you actually like live with me, I have to see your dad's side at some point. I really don't want that.
All right, so can I get y'all's attention?
Yeah.
Okay, I wanted to real quick let you know that in the last couple days, I've been working on the yeah, Colby, quiet. Been working on next 9 weeks worth of notes and stuff. Still struggling to get the notes done. Didn't help that yesterday I had a major issue. So here's the major issue. Please be very aware of my charging cable. I don't know if anybody stepped on it. I don't know what happened to it, but I usually stretch it during class. And I don't know what happened, but this little piece on the end was broken. And I had to get a new one, which was a process that took all day. I mean, all day. I went to 2 different Best Buys.
You're so good.
All right. They are so excited about this.
Is your lab done?
No, but I have to help
That's
people.
what I thought.
Okay.
All right. So anyway,
Aaron, how much is it?
there we go.
We said we'd be quiet.
Yeah. Watch out. There you go. You said to be quiet. Anyway.
Give me a diet Coke.
Ooh, Shannon, did you unloop that?
We don't have that.
Give me a Coke.
Somebody's gonna pull on it and that'll come down.
Yeah,
Thank you.
How did you reach it?
She's magic.
When I'm like right there and I couldn't reach it.
All right. So anyhow, you will definitely have your syllabus on our last day of this semester. You will most likely have some, if not all, of your 9 weeks worth of notes. If you, Henry, stop. If you don't have them, all the notes, then you'll have them shortly. Okay. It won't impact what you can and can't do because you already know your assignments. So just so you know, remember that our last day of this semester is the 17th, and we are doing our movie that day, but we're also doing the midterms that day. It's October Sky. In your in Dropbox right now, there is already a PowerPoint study guide. I'm gonna turn that into a video. I just haven't converted it yet, but it has all the same information. It was just faster for me to do than the Jeopardy thing because this is more information. It's longer.
So it's in class, the midterm?
It is in class, the midterm, and the majority of it is going to be multiple choice.
Yes.
There will be, I think it was 2 or 3 short answer, but it's multiple choice because I would prefer you to write more answers, but what I want to do is I want to be able to give you that. Yes, I want to be able to give you your semester grade that day. So I've done the teacher trick where you take the piece of paper and you punch all the holes in it, and then you lay it over top.
Oh,
so I can see where you're wrong immediately or where you're right immediately.
Cool.
So I should be able to grade everybody really fast. Yeah,
There's no essay question, but
it's just a short answer one. No big essay. And the stuff like that, I mean,
Short answer.
it's all big ideas. It's big ideas that you need to be sure you fully understand.
Well, I don't
Actually, I'll tell you real fast here.
we didn't have a midterm class last year, right?
Now it's like you're grown-ups.
I don't Miss Danny, I can't even
Grown-ups don't use school.
You need to drive.
Tires.
You're nearly there, man. Grown-ups don't do school.
You know what, Cole?
That kind of describes college.
Okay.
It does. So real quick, I'll tell you. Actually, no, it's not in there. It's in here. Where is it? Where did I put it? Oh, I know where it is. I turned off my screen share for a minute here. Isn't it just sitting? Okay, so your midterm will have, let me tell you, it's gonna have 25 multiple choice that are just straight up multiple choice. Then it will
How
have
many choices?
questions 26 through 49 are labeled the diagram.
Wait,
Oh.
How many
what?
questions are there?
Mhm.
There are 100, right?
And then 50, question 50 is a short answer 50, and then there is a bonus short answer. You also have a bonus multiple choice. So your bonus short answer is worth 4 additional points, and your bonus multiple choice question is worth 1 extra point. So you can get up to 5 extra points.
This is online, right?
Nope, it's in class on paper.
Darn it.
How long are
Everything-
we like?
We can't use.
You guys
Google
have like
now.
an hour. It's
No.
not going to take you that long.
Okay.
It really won't, because this is stuff you know. This is stuff you know.
No,
And
it's
you
not.
and you should know it, because it's all, there's a whole video a whole slideshow I've got going for you guys that
What
goes through
percent-
everything.
What percent of our grade?
Use your words.
It's the same as any other test. So it's not, I don't want to weight stuff ridiculously, because that's,
It's not like 50,000.
yeah, this is a gauge for you to know how much you're retaining, because that's what this is about. You can learn stuff for a week and move on. That doesn't say anything about your level of retention, right? And retention matters. So it's important for you to know what your retention is. All right, now I'm going back to this.
Cool, what is
Okay.
your last topic?
We didn't have.
Exactly.
Do we have finals this year too?
I am going to do a final for you guys.
Is
It's
there
going to be the same kind of thing, though.
No.
Is it in class?
Not ridiculous.
No.
It'll probably be in class, but it won't be terrible.
Can it be like in class, as in like in my classroom at home?
Which is your bed?
No,
Because
be in my classroom in my home. You're totally capable.
We're gonna be here for hours.
Am I going to make what? Bonus point? Oh, the PowerPoint thing. Yeah, I'll be sure there's a study guide for everything. When you're doing a cumulative exam, like the midterm, or even the semester quiz that I gave you, I mean the 9 weeks quiz, quarterly quiz, it's more about, did you retain the big ideas? I don't believe in getting nitpicky about things that are ubiquitous. For example, you can look up stuff, right? There's stuff you can look up. What you need to understand is relationships between things and make bigger connections. So, I mean, like, it's like taking a quiz on the capitals of all the European countries.
Oh.
You can look that up, right? What you need to understand is the relationships between countries. So that would be, he is so important once again. You're so, you gonna tell that person to shut up and hang up like you did last time?
Hey, can you shut up, please?
Yep.
there you go.
Yes, ma'am.
Will the final weigh more than other?
Oh, that's what we're just saying is it went more than the pencil because you did this one.
Wave it around. Wave it around.
Question. I have a question about weight.
Yeah, the question about weight and mass. Anyway, so on the 17th, when you come to class, you need to be here early. You need to be here at 10:30. Okay, you have 10:30 to 11:15, which is 45 minutes actually, to complete your exam. You should not need that long. You really should not. If you're worried, go to the last page, do the short answer first, because that's what takes longest, right? And then just zip back around.
Miss Danny, between 10:30 and 11:15 is the time I usually get my homework done.
Girl, you're gonna have to be your baby.
Well, then you.
There really won't be much. There won't be any homework, because the week before we will have finished. So next week, all right, next week is lesson 16, right?
Okay.
All right. So next week you'll do, flip, turn the page. I've turned the page. Oh, sorry, there it is. Lesson 16, or no, sorry, lesson 17 is next week. Where am I? Oh, today is 16. Next week is 17. Sorry, I cannot count. All right. And 17 will be, you go online and you do your, do all your stuff. You do all your normal stuff, right?
Right.
But you won't have, for the lesson 18 is, that's the lab, and I mean, that's the movie. You won't have anything to do ahead. You just have to finish everything from the previous week.
And we're taking notes during the movie, right? Like,
No,
is that
I
what you
just,
want us
you're
to do?
gonna enjoy the movie. I want you to pay attention.
Yes.
I want you to pay attention, but you're gonna enjoy the movie because it's fun.
What's the movie about?
It's about some guys who, high school boys that build rockets. They're inspired by the space race.
We
It's
bring
really
this
cool.
next again, like by.
You know what?
Are we bringing snacks again by birthdays?
Yes. So look at your syllabus, but it's where is it? January through March, sweet. April to June, salty. July to September savory, October to December healthy.
Yes,
That's
I
what you
got
bring.
savory.
What did I
Mhm.
get? What's my birthday?
It's all in there. All right, just so you know, I want to give you a quick fast forward. You come back to class on the 7th of January, and we will do mechanical waves and sound. All right?
Ew.
Then we have lesson 20 on the 14th, and it's continuing mechanical waves and sound.
Ew.
So again, those are deeper lessons because it's one subject covered in 2 lessons. Lesson 21 is on the 21st, go figure. And we are covering electromagnetic spectrum and light. Lesson 22 on the 28th, we are covering, again, electromagnetic spectrum and light. So that's 2 weeks for each of those. So that's, as you know, like only half of a chapter reading, half of it, you know, as opposed to the whole thing. Lesson 24 on the 11th is electricity. And the lab that week is actually called Detecting Fake Coins. That should be fun for you guys.
Okay,
Wait.
And yeah. And
what kind of coins?
oh wait,
Probably.
and on the 4th, sorry, we're doing optics. So it's optics, then electricity, and then on the 18th of February, the 18th of February, it is electricity again, and the lab is constructing a telephone. It should be very fun.
Can I
Very
call my
fun.
friends?
Probably not.
Oh.
And then on the 25th, we're doing magnetism, and your lab is making a compass.
Awesome.
Yeah, they're going to get really fun in these next couple weeks.
Yes.
Are you telephone or telegram?
It says telephone, but I don't know. On the 3rd of March,
Which
again,
phone?
is more electricity,
Exactly.
and it's going to be building an electric motor that day.
Oh, that's
That should be very cool. And on the 10th of March, this is when we switch out of our physics type units and move towards our chemistry units.
when
So this is when suddenly your amount of reading is going to increase, but the level of stuff we're going to cover is higher level, right? Not the really deep stuff. It's the high level, high and wide. Remember we did high and wide? Now we're doing like narrow and deep versus high and wide. There you go.
Oh, wait,
So
yeah.
on the 10th of March, it is properties of matter and states of matter. Ooh, that's totally the wrong
I
word.
literally wish you would just fall off of something and hit your head so hard.
Oh my gosh, you guys.
Like,
You were talking to Danny at first.
Oh man.
No.
Then so he
I
laughs
want you to
now.
forget all your dirty-minded stuff.
no.
All right, back to this.
Before you did.
March 17th, St. Patrick's Day. Atomic structure, and it's going to be modeling an atom. You guys are going to get to model an atom. The 24th of March is organizing, the periodic table, and you guys are going to do periodic table battleship, which is paired up in partners, and it's fun. It's fun.
Cool.
Then we've got one more before spring break, and it is on the 31st of March, chemical bonds,
Okay.
and it's comparing ionic bonds and molecular bonds, all these different kinds of bonds, and I have a spelling error right there that I can't see.
Bond?
Bonds.
I have a
Bonds,
special request.
James
Yes.
Bonds.
I'm not
Hey.
sure what you have planned for April 29th, but if we could blow something up on April 29th,
All right, let me see.
it'd be absolutely
So we have no class on the 7th. On the 21st, the 21st of April is solutions, acids, bases.
What happened on the 14th of April?
Oh, did I skip that? I did. Oh, it's right here. It's chemical reactions again. More fun chemistry stuff. And then our last class before we start our Rube Goldberg machine is carbon chemistry and nuclear chemistry.
so that means
that's
blow
28.
stuff up, right?
I'm not sure. I'll have to look and see. I have the lab written down somewhere else because I didn't
Well,
get it in
nuclear
here.
chemistry.
Then I want to make sure you guys are following me here.
Here.
Lesson 36 is our last lesson. And it is not a junior lab rats lesson. It is a rat pack combined lesson. And it is
Why?
May 5th, May 12th, and May 19th.
Are we gonna have to sit in the same
It's
class?
the Rube, you're not sitting, it's the Rube Goldberg competition.
Oh.
So
Going down.
class hours for those
I'm not
days
going with.
are from 10:30 to 12:30. That's it. If you want to hang out later, you can, but it's 10:30 to 12:30 that I expect your teams to be here. The 5th is slated for brainstorming, collaboration, design, begin construction. The 12th is continuing construction, and the 19th would be finalize and compete. But if you get everything done on the 12th, we don't have to come to class on the 19th. We could have our summer start a week earlier. Whichever day we end, be it the 19th or the 12th, it's currently slated for the 19th.
Like me.
You are welcome to hang out afterwards and go to the pool like we did last year, but you have to pack your own lunch, your own sunscreen, all that good stuff. And if you're under 13, you need an adult that's not me. Yeah.
Okay, so for like lab teams in spring,
Yeah.
I want Drew.
I know you do.
I want him back.
Yeah, I know you have made that very clear.
And
Do you think well?
I think my grades are,
Do
I
you
mean,
think well?
they're okay.
They're good.
So I think I should be allowed to request Drew. Because
So
he
I will
has
take
been-
volunteers.
Drew
Okay.
Sakasi in 2020.
Here's what I'll do. Here's what I'll do for you guys. For final lab teams, for Rube Goldberg stuff. All right. I will take volunteers to be captains, no more than 4.
I'll pass.
And wait till we get there, wait till we get a little closer. And each of you may choose one person, maybe 2 if y'all are really good. And you'll tell me who they are, but I'm not going to tell them who they are. I'm just going to assign teams. They don't have to know who you chose.
If your grade is above 95, do you choose 2?
Hello.
What is mine? I think it's 96.
Oh my gosh, y'all crack me up.
Mine's 60.
Your
All
grade's
right.
not
No, it's
60.
not.
I'm senior 61.
All right.
One.
So that's that. Let's go on ahead and get to today's lesson. So if you guys got your notes.
Miss Dan?
Yes, ma'am.
I'd like to ask you,
Mhm.
could you repeat the order of the midterm, like the,
Midterms, yeah.
yeah.
So it's 25 that are multiple choice. Is that what you're asking?
Yes.
Okay. 1 through 25 are multiple choice.
So,
Yep. 1 through 25 are multiple choice. And whatever the next one is, 26 through 49, I guess it is. Those are all label a diagram, which does come out as multiple choice. Like, you know how we link the letter in the diagram? It's fill in a circle.
So well.
Yeah. This time it's on paper, so it's a little better. Because, man, it is hard. I can't see the two screens at one time, and it's maddening. All the time. I'm like, what? And then the last one is there's one short answer. And then you get bonuses. Yes.
Are the juniors doing the same exact?
No. Theirs is much shorter, and it doesn't get anywhere near as
Why
involved.
can't ours be shorter?
Because you're so smart.
Aw,
Yeah.
suppose.
Yeah, the juniors is much, much shorter than y'all's.
Did you tell them how many, like,
I did not yet.
okay.
That I'm going to. We got to a side tangent today on everything because they were very excited to see each other. So, all right. So, moving on to today.
It's about mama.
We're talking about energy and its forms, right? All right. So, I have this guy here, which was in one of the books to try. So, basically, I took a little card, and I folded it in half, and I put little slits in it, and then I actually taped because it wasn't working well otherwise. But the idea is supposed to be, hold on, let me flip this
Me and my dad
camera.
had a debate. Is a squish down spring
Whoops.
it has potential energy? It does, right?
Of course.
Yeah.
Okay, so if I take this card here, where is it? And I flatten it out.
My dad said it
Like-
has potential energy. It's just sitting there.
What? Yes, it does. If I take this card like this, and then I let go, what is going to happen?
It's gonna
It's
spring
fine.
up. Boom.
Okay.
No, it's not. Yes, it is.
No, it's not. Yes, it is. So see, it's got, I'm showing this to Lily on the camera, got a rubber band wrapped in here. Let's try it one more time.
Are you live streaming?
It's not, I don't think, well, yeah, but she's probably not going to find it until after class. So what? Obviously, you see what that does. What if I do it this way?
Oh, no.
Let's
gonna-
have
it
a-
might
like,
turn
a-
it up.
a-
Oh.
Yep,
Called it.
slam shut, right? Okay.
It did something.
So what did, when I take this rubber band and I stretch it out, what am I adding to it?
potential energy.
Yeah, specifically elastic potential energy, right?
Yeah.
All right, so, all right, there's that.
Okay.
The best example of elastic potential energy, hopefully if I say this, you'll never forget what it is. You ever been walking in a line through the woods with other people, and the person in front of you has a little branch, and they push it out of their way,
Yeah.
Bam.
and then they let it go,
Uh,
and you get smacked in the face?
I do it on
I've done
purpose.
that.
Yeah. Yeah, so they've created the elastic potential energy. All right, how about, Henry? All right, so how about this one? What's this called? Does anybody know? Newton's cradle. All right. If I, okay, Ethan, lift one end up here. All right, so now what did you just add to it?
Gravitational potential.
Gravitational potential energy. All right, now go ahead, let it go. Okay. Somebody want to tell me what's going on?
They're rocking.
They are.
The energy is going through me.
Correct. What do we call that when
Energy.
that, okay, so right. Couple things going on. You're right, Aaron. So when we lift it like this, we have created gravitational potential energy, right? Because gravity is going to pull it down. Once it starts moving, what does it have? Kinetic energy. And then when it hits, why does the one on this end then move?
Because
It's the same force.
Right. So it's being transferred, correct? You have an energy transfer from one pendulum to the next. Wow. I can't see well. Yeah, no. They know when they go. Stop. Here we go.
Okay, so I have a question for everyone. What happens? How many is there? Is there 4 or 5?
5, I think.
What happens if you pull 4 and then let go? How many comes out?
It goes bad.
Oh yeah.
Anybody want to guess?
You just switch it. They're always gonna be one on the
Yeah.
side.
Yeah.
4 more go down.
It's 4 and then 1.
So why is that, Michael?
It's because it's the same amount of force.
Yeah, we're
It takes
transferring.
1 to
5.
So it has to do with if you guys look, if you look at the little boxes on the right hand side of your notes, where it says kinetic energy there, do you see that one of the options is mass? So if you increase the mass, you're going to transfer. Well, I keep dropping it at a weird angle because I can't see it.
You want me to do it?
They're
There you go.
They're not very good quality.
Yeah, well, I don't think I got this from wish.com. I think it was Amazon. I get a lot of things from wish.com, y'all. There we go. Now that's straight.
Nice.
See that?
Nice.
Right?
Wish.com is awesome for some things, not for other things.
What do they even have?
Everything, Aaron.
Literally name something.
Name anything, it's there.
And it's like 20 cents, and then you pay $9 to ship it. All right, so
Wait.
energy, yeah, exactly. So, hang on. So now this guy. All right, now. Let me ask you one more question about the Newton's cradle. If I let this ball go, is it gonna go forever?
No,
No.
Why not?
because
the energy is
some energy is lost.
How's energy lost?
Friction or
It goes forever in smaller and smaller
Friction
amounts.
predominantly, yeah. So, yeah, there you go. Drag is a type of friction. So yes, absolutely. So the energy is not being destroyed, right? It's just being converted. All right, so what if I took this thing,
Spin it.
Okay.
Yep.
Go spin it.
let me let it go all the way up. Okay, here we go. Now, will this go forever?
no.
No.
What will stop it?
The friction in the middle.
Well, let's watch it. Is it slowing down?
Yeah, it was because originally it was going around in the full circle. No, it doesn't have
Mhm.
energy design.
Well, the friction.
But now
that
look
the
at it.
axles are on will stop it.
Is it stopping?
No, looks like it's staying in about the same.
So now we have to think about this. If it's not stopping, then what's happening? Can you have a perpetual motion machine
Yes.
Well, this
with
that's
no
what-
additional energy added to the
No.
system?
No.
No. There is a battery, but what's the battery powering?
A magnet.
Ah, look at the bottom of the round piece. See the bottom of it? What's on it? A magnet. Okay. Look, it's even threatening to go all the way over.
It's getting higher.
Oh.
Yep.
Yes. Yes.
See
yes.
that magnet? There's a magnet in it. Yep, there's a magnet in the base. Okay. So that magnet in the base is either pushing or pulling, depending on how it's passing above it. So if it's pushing or pulling, then what is that? That's a what? The push or a pull is a
Of course.
force. So we're adding force and energy then to this system. which is the only reason that it's continuing to go. It's kind of mesmerizing. You could stare at it for hours. But if that magnet wasn't there, it would stop,
It's getting higher.
right? I know it's kind of, it's okay. Whoa. Oh, it's like watching the ball on the,
On the TV.
yeah. We're gonna go. Let's watch it go one more
The
time.
DVD in the corner.
One more time.
Yeah. I was thinking.
Ready?
Yeah.
Oh.
Gotta go next round,
Okay,
next
one more
round.
time. Come on, come on, come on, come on.
No,
Oh.
next
Next one, right, Aaron?
No,
what?
Wait, it's
It's
it's not this one. This is rigged. It's rigged.
It's funny how much of you are doing this right now. Like, I'm doing it. So many of you are moving your. Oh. One more.
This is it. I know it. I know it.
Oh my gosh.
You're jinxing it.
That's it.
What?
Oh.
You said it. Stop.
That's it. That's it. Right there.
Yeah. Here we go.
Aaron called it.
There you
You
go.
called
Yes.
it like 5 times.
It's on 17.
Hey,
Huh?
though.
It's all already in your syllabus. Everything's already in there. All right, so let's look at our notes.
I'm looking.
All right.
These are curious.
What is letter A about? What kind of energy?
Energy and work.
Energy and work. Okay, so energy. And what is energy?
The ability
The
to do
ability.
work.
Mm-hmm. Very good. So work is a transfer of energy. So we have kinetic energy, and that's what kind of energy? Energy of what?
So the longer you stay in school, the more
Energy of
you
motion.
have.
Yeah.
No.
Kinetic energy of any moving object depends upon its mass and speed. So look at the box on the right where it says kinetic energy.
Yep.
Depends on its mass and its speed. So you've got velocity there, which involves speed, right? Speed and direction. And then you've got mass. So let's think about this. Its mass and its speed. If I had this ball and it was, say, 5 times this big,
It would be big.
and I let it go,
It would be big.
all right?
Are the others the same size?
The others are all the same size. The only one that's changing is that one.
So,
What?
So one is exponentially bigger.
One
than
is
the other?
exponentially bigger than the others.
Well, then
What?
It'll push all of them
Right.
too far.
It's gonna push, but I'm asking, what I wanna ask is, what happens to the energy in the system if we increase the mass of one of these balls?
It'll mess it up.
It'll increase, because if you look at the formula there for kinetic energy, it's got mass and velocity multiplied towards each other. I mean, yeah, with each
Make
other,
the
right?
child Super big.
So if you've increased the mass or the velocity, you're increasing the overall kinetic energy. So think about it this way. If you had to be run over in the street,
Oh, God.
would you rather be run over by a semi-truck or a guy on a bicycle?
Semi-truck.
Yeah, you just want it done, huh?
The guy on the
Let me put it this way. Would you have less injury if you're run over by a guy on a bicycle or a semi-truck?
You'd be dead.
It depends,
All
man.
right, okay. So obviously, the bicycle's gonna do less damage because it has less what?
Wait. With the
Mass.
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 If you get hit by a semi-truck, you could fall over and then it rolls right over you.
Only you, Aaron, would say that. I'm just,
I feel like Kendall
What
would
if
say
the
that.
wheels
don't roll over
but see, Aaron would try it. That's the
What if
difference.
Like a train, if you like lie down on the track.
Yeah, like if it hits you, then you fall
Except
down.
the
on
train's
your back.
on
No,
track,
no,
so
no,
it'd be
no,
like
no,
No,
over
it
inches.
won't like hit you and then you just like fall over and
Or
then
we're
it goes.
talking if the wheels right over you.
Yeah, at first
Yes.
it's probably good.
That would hurt.
Dude, it's the worst.
Well, it depends. If the bike's coming at me, that's gonna hurt. If the truck's
All right,
coming-
so
What if the bike falls on you?
So listen, because you're multiplying mass and velocity times one another, if one of those numbers increases, it's going to increase your overall energy, right? So if you get hit by a semi-truck versus hit by a little guy on a bicycle, there's going to be more energy in the system. All right, now think about it this way. You got 2 semi-trucks headed towards you. One of them is going like, let me see.
$1 million.
It's going like 5 feet per second. It's inching forward. Let's say 2 feet per second or a foot per second. It's parking. Okay, versus one going 55. Which one is gonna do more damage?
The 1 foot.
Because 55, because now you've increased the speed. So either the velocity speed or the mass increase, the overall energy is gonna increase.
I
right.
almost got hit by a car one time.
That's cool.
I got run
you
over
almost-
once.
You almost pushed me into a car one time.
I almost ate
Wait,
that
you
once.
got hit by a car one
No,
time?
I got run over by a car that was supposed to be parked.
Oh,
Long story.
that sounds.
We were saved by my mother's hair. That's not a lie.
Wait,
That's the
wait,
honest to
I
God
wanna hear the
truth.
story.
Let's
Okay,
time.
Come on, go on a tangent.
Okay, come on.
When I had my permit,
And I
permit people,
Like,
I had gone to the mall that night with my then boyfriend, and we like walked around the mall, and then I went home, and my mom wanted me to drive home. So the week before, my mom had parked her car at the bottom of a friend's driveway, and her daughter, who was like a year older than me, backed out of the driveway and hit my mom's car right on the driver's side door, kind of like where, you know, where the door and the frame come together,
Yeah.
like right here, and dented it. So the door opened, but it didn't open all the way. It opened like this much. You could get in and out. We were waiting to take it to the body shop. We had an appointment. So anyway, I drove a little dented car home, and we had a steep driveway, kind of like this one. But I didn't want to pull all the way into the garage because that scared me. I didn't feel ready for that yet. So I stopped at the top of the driveway, and
Didn't pull
I-
parking brake.
no, I did pull the parking brake. And then I got out and started going to the house, and my mother was like, come back, you have to fix this seat, because my mom's 6 inches taller than I am. So I had the seat all the way forward, and she needed it moved back. So this is one of those cars where you reach under the seat and pull the lever and then push, not, you know, it's go that kind of thing. So I stood there in the doorway with my feet on the ground and my mother behind me and pushed the seat back, and the emergency brake actually collapsed and fell down. It was one of those ones in the middle, and it fell down, but it wasn't in gear. And I didn't realize it wasn't in gear because I wasn't used to driving enough to know that I hadn't put the car in gear. So it was in neutral. So it just started well backwards. So here comes your kinetic energy. The car starts rolling now, right?
Right.
And it hits me, and then I hit my mom. And so we both kind of were caught in the door frame like this, going backwards down our very steep driveway. And my mom started to slide, and I started to slide. So we both kind of fell, and like my mom's legs were like that, and I was kind of half sitting on her, but I was kind of like this.
Okay.
And then my right leg got caught under the tire. And instead of rolling over me, it just sat and pushed all the way down, like shredded the whole outside of my right leg.
Oh my God.
All the way down. And this is what I mean by my mother's hair. Okay. So now we've got a lot of energy, right? We've got a lot of mass. It's a car, a lot of mass, and it's going down a slope. So you've got the gravitational thing going on too. But my mother's hair was a little shorter than mine is now, but her head was leaning back further and further as we got pushed. And her hair got wedged between her back and the driveway like this.
Oh my God. How?
And it stopped the whole car. Her hair, her whole shirt was shredded, like her whole back was scratched up. But her hair was like, you know, so she,
Oh my God.
so once her hair had stopped the car from moving, these guys that hung out with these teenage boys were really big guys. They came running over and they pushed the car off. And then my mom did one of those weird, you hear about those weird adrenaline things where people like move cars? Well, she's sitting on the ground with me on her lap, and somehow she lifted me from this position and threw me. And I landed in the yard like she threw me like 10, 12 feet. I mean, from sitting on the ground, you know, with just pulling her hair out from behind her head. It was weird. She was like, "Phew," and then that was anyway. So energy will get you. Energy will get you, and your hair can stop you.
Moral of the
Okay,
story,
everyone
move
cool?
the seat back when you're done driving.
Yeah, and put the car in gear. So it wasn't even a huge car. It was a Toyota Corolla,
I'm
but
wearing a full-on jacket.
there you go. So potential energy that is stored as a result of position. And there's two kinds of potential energy, right? One kind is gravitational, and the other is elastic. So we just talked about gravitational when we dropped this guy here. And then we talked about elastic when we stretched this fella, right? So gravitational depends upon an object's height. So here's an example for that. Would you rather be forced to walk the plank by a land pirate off of a 10-foot jump or a 40-foot jump?
40 foot.
Ah, man, you are in for it today. So,
Here's what I done.
yeah, I'm not saying would you rather anymore. I'll just say, would you suffer less personal injury? So anyway, obviously, if you look at the formula there for gravitational, if you look at the formula for gravitational potential energy, do you see what, okay, so can somebody read me the formula, but substitute the variables for the words? Like, what is it? If you could read it as a sentence. Anybody want to try it?
Which one? Kinetic or?
The gravitational potential energy.
Okay.
So,
Wait a minute. Michael's going.
Gravitational potential energy equals mass times gravitational field strength times height.
Okay, there you go. Mass times gravitational field strength times height. So if you increase the height, like from how high are you jumping or falling, you've increased the energy. And if you increase the mass, so think about this. Who is going to suffer, guys, who's going to suffer less injury? The elephant that jumps off my deck or the mouse that jumps off my deck? Who says the elephant is going to suffer less injury? And who says the mouse?
Everybody else.
oh, you.
The mouse has
Oh,
less
yeah.
mass, right?
Wow.
Haven't you ever seen mice like jump on, like, ever seen a squirrel fall out of a tree?
They're fine.
Yeah.
Have
you ever seen it? It happens on occasion. They don't do it often because they're so adept up there and so coordinated, but occasionally a squirrel will miss. And when they fall out of a tree, they're like, "Wah," you know, they come out and their little tails start flying, but they hit the ground and then they just run like it's nothing. If you fell out of the tree, you'd be hurt. Yeah. You weigh a lot more than a squirrel. All right, so then if you look at the elastic potential energy one, that one says that it's the energy of an object that's stretched or compressed. So that formula is elastic potential energy equals 1/2 of the spring constant times the extension. So the spring constant is, it has to do with how flexible or how rigid a spring is. For example, some springs, like on a trampoline, are pretty flexible versus the kind like in a truck suspension, right? And then you've got extension, that would be how far you've stretched. Can we put that away? It's just an ice pack. I
I
understand
don't
why
know
it's-
what's going on.
It is a fascinating ice pack. Okay. Yeah. Odd thing to do. All right. So forms of energy. All right. Somebody want to tell me what different forms of energy we have that fall under the kinetic umbrella?
Mechanical.
Go ahead, Cole. Wait, Cole raised his hand. Go ahead.
Mechanical, thermal, chemical, electric, electromagnetic, and nuclear.
No.
No.
No, that's what it says right there. Forms of energy.
Do you,
On
on the little graph.
the graph. Okay.
Okay.
Mechanical, thermal, sound, electrical, and radio.
Okay, good. Those are kinetic forms of energy. And how about potential? Michael,
Mechanical, gravitational, nuclear, and elastic.
did you say nuclear?
Nuclear.
You know I love you.
Yes.
Why?
It's nuclear. I even wrote this for the last class because I was like, dudes,
Bros.
don't do it.
Nuclear.
Don't do nuclear. It's not right. He does it because he knows I don't like it. So
Wait,
he's
why
just
is it-
trolling me.
I do
Wait,
that.
what is it?
Yeah. Nuclear. Because it's from a nucleus. It's not a nucleus. We've messed it up because we abbreviate it nuke and then people just go nuke you instead of nuclear. Anyway.
Nuclear.
It was one of the things that George Bush did every time he spoke. He every time he spoke about nuclear energy or nuclear weapons, and which happened a lot because they were talking about weapons, right? Let's go find weapons. And he used that word wrong about 100 times. And every time he did it, I wanted to jump through the TV and smack whatever handler wasn't telling him to fix it. Because clearly somebody had to point out to him it was wrong, but he was just going to hold to it. So mechanical energy is associated with, oh wait, let me ask you this first. So under potential, can somebody give me an example of potential energy that's chemical in nature?
Oh, I can't.
Okay, who can?
Thank you.
Who can?
Yeah, acidic liquid.
Nobody can give me a potential?
Yeah, acidic
Cole, what are you
liquid.
eating? There you go. Thank you for the example.
Wait, what?
Mhm.
Hamburger.
Yeah, food, right? Food is chemical energy. It's potential. It's just stored in the food until you eat it,
Oh.
right? All right, yeah, boom, right? We understand elastic and gravitational, and we understand nuclear, right? Why is nuclear energy potential energy?
I'm sorry,
It
I'm
hasn't
not.
been detonated.
Yes, it's stored. It's not being used yet, right?
Wait, I'm sorry, I don't know what the difference is between nuclear and nuclear.
No, nuclear, not nuclear. Nuclear is not a word.
Nuclear. Except
Oh, okay, cool.
Nuclear. Think about it as
It's a nuclear.
nuclear. It's nuclear power.
Nuclear.
Yeah, there you go.
Oh, okay, I get it. Sorry.
Yeah, you get it.
Nuclear.
So mechanical energy, all right, that's associated with motion and position. Somebody have an example. Who can give me an example of mechanical?
Potential.
Robot.
Or kinetic?
We're in, yeah, mechanical energy. So that would be a type of kinetic.
Um.
In nature.
In nature?
Yeah.
No, anywhere.
No,
It doesn't have to be in nature.
Well, whatever you move.
You're making up all the rules, Cole.
You
Whatever
said
you-
Yeah.
Whatever you move.
Yeah, so it's energy.
Every second of your life.
Yeah, so the little graphic to the side there says energy due to motion of an object. So you're riding your bike, you got some energy, right? There is your mechanical energy. That's your bike moving forward. All right, how about thermal energy? That's total potential and kinetic energy of objects, microscopic, that should be a possessive, nobody caught that, huh? Of an objects, look at that twice. Of an object's microscopic particles. All right, so we're gonna get to this shortly when we do, when we do temperature and heat and all of that. But temperature of an object is a measure of how fast its particles are moving. That's what it is. Heat is the transfer of that energy from one thing to another. So, for example, when you step on a tile floor in a bathroom, how does it typically feel to your feet?
Cold.
Cold. All right. The temperature of the tile is the same temperature as the rug that's also on the floor. They're the exact same temperature. What it has to do with is conductivity. So it's about you stepping on the floor and the heat from your body being conducted out into the tile. That's why you feel it as cold. You perceive it as cold, but really it's 71 degrees or whatever your bathroom temperature is. So, I mean, everything in here, like this table is the same temperature as this cup or this. They're all the same temperature. They don't feel the same temperature to you, right? Okay. So chemical energy. So that's energy that's stored in chemical bonds. So a great example of that is food. Another example of that would be like wood that you haven't burned yet, right? And electrical energy is associated with electrical charges. So that lightning,
Static.
yeah, dealing with electrons. Yeah, everybody's probably been shocked before with like static electricity shock, right? Not, I hope y'all haven't stuck your finger in light sockets, because that really hurts if anybody's ever done
Oh,
I touched the light.
I did it once as a kid, and it was like horrible.
Yeah,
Horrible.
I got
like
like good one
it.
time.
Yeah, so when my brother's like,
I've done that. I'll check my hand.
Yeah.
a knife, no, a bobby pin.
Oh.
Bobby pin into it, and then a whole like they had to
Oh,
turn
yeah.
off all the lights and stuff.
Oh yeah,
I
yeah.
was plugging in like a 1 o'clock one time at night and I couldn't see anything and I had already got the
Touch the metal.
prongs
And how much
halfway in
they
the socket and then I put my finger in the prong.
It'll do it. It's a terrible feeling. It hurts, like your whole, you can feel it move through your arm or whatever, and it's like,
One time I was trying to plug my charger at night and I didn't see it, so I
Yeah.
just stuck it in the wall.
I've done that.
man, you are on a roll today,
Like you put the
Freddie.
prongs through the drywall.
Your mother must
I was
love
like,
you.
I'm like, oh, I can't.
Yeah, can't find
That's
the charger.
skill.
So then we have electromagnetic energy. All right, now someone give me an example of electromagnetic energy.
The pole.
What?
North pole.
Electromagnetic energy.
The
There's magnetic, yeah. All right. How about this?
have they turned on and off?
What is the electromagnetic spectrum? Does anybody remember what that is? Are you guys cool over there?
Yeah.
Do you remember what the electromagnetic
It was-
spectrum is?
Colors. Right?
Okay, we can see a portion of it, which is visible light, right? We can see this little chunk in the middle, that's our visible light. But then we have waves on either side that are like X-rays and radio waves and gamma waves and gamma rays, I can't talk, UV, all that business, right? So all of that is bombarding you right now. Like you can't see any of that. You can only see the visible light part of the spectrum, but you're being completely bombarded by all these other types. So it's always here, you just don't see it. But it's you know, you can turn on your devices, you can turn on the radio, right?
Is it on us?
Yeah. Oh yeah. Absolutely.
Can we shout to get it off of us?
No.
No.
So then, and nuclear is pretty obvious. That's stored in an atomic nuclei. So what happens if you split the nucleus of an atom?
Boom.
In you.
Hiroshima.
Kaboom, yeah. Hiroshima, Nagasaki, kaboom, right? That's what happens. Really bad.
That's all.
Yeah,
Why
really,
would we
really bad.
laugh at that?
So,
You said Cuban.
No, it's really, that's what I'm saying. It's really, really bad. You split.
Not good.
Yeah. People die. Not good stuff.
Wow, you're not gonna touch those bad.
Well, I mean, you could argue that there are appropriate uses, but it's still not going to be good for whoever is on the receiving end. Let's put it that way.
Appropriate.
There was another perspective.
People could argue.
At the time,
So-
it was good for us.
So
Military.
Not
Military.
really.
From the military, it was a success.
there's lots of
You
arguments
sound
about
like
that.
every American
So
ever.
these scientists that it didn't work when they
I mean, it worked.
We've been working
It
for
works.
6 years on something.
But
I'm
like,
not saying it's
There's
working.
argument that it was terrible. There's also argument that it ended the war and actually in the end
Saved
produced
lives.
less, saved lives, produced less damage as far as lives are concerned.
That's
There's
good.
arguments
America
anyway.
just really
But
had
it's
to
not-
one up Japan though. Like,
They were like, oh, you want
little bomb on Pearl Harbor, and then it's like, humongous
Japan
bomb.
likes to one up.
You seen the ping pong video?
All right.
Oh yeah.
Back on topic.
Back on topic.
So now we have energy conversion and conservation. All right, so there is a difference between saying the conservation of energy and conserving energy. The conservation of energy is the law that states that energy cannot be created or destroyed. It's only changes form, right? So if you look here, if we look back at this guy, all right, we talked about this before. So now we have potential energy. As soon as we let it go, it's kinetic, right? It's hard to hold it still. But yeah, and it's shaking into my hand too. I can feel there goes some of it. So what?
Do you have any examples of nuclear energy in your house?
No.
No,
I don't know what that is. So no. Yeah.
You got any nuclear energy?
So energy conversion is it changing form. Energy conservation, the law of conservation of energy, states that it can change form and it's not created or destroyed. But then conserving energy means what? What does it say? If you say conserving energy, it doesn't mean the same thing as conservation of energy, which is kind of tricky. But so conserving energy is what Al Gore wanted us to do last year. Remember when we watched An Inconvenient Truth?
That man.
Conserving energy is about not wasting energy versus conservation of energy, which means that within a system, energy is conserved or changed. Henry, please. Not created or destroyed. So if you look,
Henry's a strong and very
yeah. So
He's like a cat.
energy can be converted from one form to another. Energy conversion is the process of changing energy from one form to another. Conservation of energy, the law states that energy cannot be created or destroyed. Energy conversions, the gravitational potential energy of an object, for example, guys, is converted to kinetic energy of motion as the object falls. I will get a phone basket for y'all's phones.
No,
Then
I'm not
don't
on my
mess.
phone. I was trying to figure out when Kurt Cobain was born.
I was trying.
Like
Why?
legit, I was paying attention.
When was he born?
1967.
I was gonna say I know he's older than me, but I don't know how much.
He died
There you go.
1994.
I was there, man. I remember. Not there, but I was
wanted
alive.
to be there. I couldn't stop him.
I was alive, man. I remember.
Wait, so I swear to God, I was totally paying attention. I just need to figure that out.
So, yes, ma'am.
I
For a
was telling
social
Lily
experience.
about the midterm.
Ah, Okay,
That's
cool.
what I was doing.
All right, cool. So, other examples of energy conversion. So you have an alarm clock. It converts your energy from electric to sound energy, right? Then you have a battery. That's chemical energy in a battery, and it is changed to electrical energy when it's used. Then you've got a light bulb. That's electrical energy, and it's changed to thermal energy because you know how hot they are if you try to unscrew one that just blew up or whatever.
Oh, man. I hate those.
You wish you didn't.
I touched one goes on.
You shouldn't do that. So a blender, you got electric energy to kinetic energy or mechanical energy and sound energy. Why does a blender produce sound energy? What's going on?
Because it's blending stuff.
But what's causing the sound?
The motion of the stuff.
The motor.
What causes sound in general? Yeah.
It's the things pushing air out of the way.
There you go.
Sound.
Yes. So sound is created when the atmosphere air within the atmosphere is vibrated or either compacted or moved around quickly, causes waves, right? So hair dryers, you got electric energy that goes to thermal and kinetic, sometimes mechanical, and yeah, that will produce sound because again, it's moving the air around. And then a fan, it gives an example. You get electrical energy and it's converted to kinetic or mechanical.
And sometimes
Yeah. So if you look at the little formula on your paper that says conservation of energy, it says that the sum total of the kinetic and potential energies in a system, the total mechanical energy is the sum total of the kinetic and potential energy. And it even gives you a little like EI equals EF. See it? There you go. All right. Now, real quick,
So when I is equal to
I'm
F.
going to change something, and I want you to change it in your notes because I found it inaccurate, and Jason pointed it out because he saw me typing it up the other day, and he was like, that is not very clear. And I was like, nope, you're right. So under energy and mass, letter D, number 1 says Einstein's equals MC squared says that the energy and mass are equivalent and can be converted into each other. Equivalent is not really accurate. What it should say is proportional. Do you understand the difference?
No, because one E is not equal to 1 M.
Correct. Proportional.
It's a big
PRO.
word.
Shut up, Michael.
PROP.
It's P-O-R. P-R-O, that's pro.
And you might see that on your midterm, and you will see it corrected if you happen to see it.
Oh, wow, look at that.
Did everyone catch what I just said?
No, I
Okay.
can't. Because these two
I know.
were owing.
I said they were owing. I said
Oh.
you might catch it on your midterm, and if you do, it will be corrected.
Cool.
All right. So
It's gonna be able to judge that.
non-renewable energy sources. So non-renewable energy sources are called such because why?
Because they're non-renewable. Oh, because they exist
Made
in
of
limited
fossils.
quantities. They cannot be replaced except for
Right. Millions of years.
Wait.
Huh.
Doesn't that technically mean they are renewable? We just have to wait millions of years.
Yeah, but they're not going to be renewable within our lifetime,
But the
so
definition of
we're just going to call them non-renewable.
Oh, snap.
So,
I'll make
Cool. Hush. So those include what? Fossil fuels. And what are the main fossil fuels? Coal, natural gas,
Coal.
oil.
I did
And then
it.
uranium they've
Coal.
added here too. Because we use uranium for what? What do we use uranium for?
Power.
Nuclear power predominantly, yeah, and weapons, but nuclear power, and it's really not renewable. We're not going to go make more uranium.
That's good.
Like, oh, we used up all today's uranium. Let's make tomorrow's. It's not going to
Time machines.
work that way. Yeah. Okay.
That's what's on
Take
there.
CEO here.
Yes, plutonium. So renewable are those that can be replaced in a relatively short period of time. All right. So those would be things like, y'all okay with it? Hydroelectric, solar, geothermal, wind, biomass, and in the possibly in the future, stuff like nuclear fusion. You know, like in Back to the Future when he comes back and he has Mr. Fusion on the car and he pours like all the
Yeah.
I love it.
He's awesome.
He is awesome. So hydroelectric comes from what?
Water.
Water. Okay, think about it for a minute here. What kind of energy does the water have
Hydro.
that produces hydroelectric? If it's producing hydroelectric,
Gravitational.
think about it.
Kinetic.
Okay, what happens over here at the dam? They open up the dam
Turbines.
and the water comes through the turbines and spins. That starts the generators, right? All right, so what kind of energy does that water have as it's moving through? It's
Gravitational.
moving, so it has kinetic energy if it's moving. What does it have when the dam is closed?
Potential.
Potential. What does it have if it's at the top of a waterfall? Gravitational potential, right? It's going to come down, right? So water that is used in hydroelectric is taking advantage of kinetic energy that is nearly always typically caused by some sort of potential energy holdup that causes it to move along, right? So solar comes from the sun. Yeah, okay. And where does geothermal come from?
The Earth.
Yeah, Earth, yep.
Oh,
Biomass is going to come from what?
every living thing.
Living things, right. And hydrogen fuel cells come from hydrogen and oxygen reaction.
Wow.
So here's a question. We started this little device going, our Newton's cradle, all right? And when it's moving, it's kinetic, right? We've decided that. When it's here, it's potential. So did I just introduce this energy out of nowhere to get it to here?
Yes.
How did I get it to here?
You moved it.
I moved it. With energy from me. Where did my energy come from?
By
Not from you. You take my
said
energy.
heart.
Oh, no. Thought you were tapping and saying from me. I'm like, no, you suck the energy out of me. You don't provide it. Okay, so I know. Yeah, I know. It's true. No, it didn't come from your heart. Where does your energy come from?
Sun.
Eventually the sun. Where does it come from first? I just ate that delicious blondie that he made, right? So that was full of food, in our case, sugar, right?
Oh,
And so I got my energy from that. And when it was stored in the sugar, it was what kind of energy? Yeah, it was chemical. Yeah, potential chemical. And where did the sugar cane get its energy from? The sun. So unless it involves gravity, typically all energy is going to come eventually from the sun. It can be traced back, all the way back. It's like the battery of the solar system. What are you yakking about,
I
Cole?
thought she said I was food.
No.
You are food.
I've been saying something completely different. You keep saying really weird over here.
It looks delicious.
You are food for the glip globes.
Eat his liver with some
For the
fava
what?
beans
For the glip globes.
and a
You know
side
those
of
aren't
Chianti.
really-
No, anyway.
really-
Let's So, conserving energy resources. So energy resources can be conserved by reducing energy needs and increasing the efficiency of energy use. That makes sense, of course. So energy conservation is using less energy or using energy more efficiently. So you've got energy conservation and then you've got conservation of energy, and they're not the same thing. So it's got types of energy. It's divided. You can see these pictures, right? You got renewable and non-renewable, right?
Looks like when Pokemon, which does damage.
So here's an interesting thing I read. So wind energy is real popular these days, right? Wind farms. Yeah.
All the brain.
So here's something to consider. I read a thing the other day about wind farms, and apparently they the blades don't last forever.
Yeah.
And what do you suppose they do with them?
They have to recycle them if they're too big.
They're not recyclable.
Yeah.
So where do they go?
Landfills.
Landfills. Yeah.
Why are they
Wait.
You can't melt them?
That's
Nope.
not
They're
good.
way too big.
They're
They
not.
probably cost
They're
much
too
to
big,
buy.
and something to do with their construction and
That's like some vegan.
like the composite makeup. Yeah. So just
vegans,
remember.
not really doing anything for the environment. Like
They just eat the environment.
they really
Wow. Comment of the day. Sorry, that was just too good. They eat the environment.
They're actually doing good though because they don't eat the animals and stuff. And
no, but like sometimes
But
you
the animals are
never-
renewable.
But the animals
Yeah.
are there,
They're
so we can do that.
renewable.
actually, if you
What actually?
Wow.
like the
Y'all are
work it
amazing.
takes into feed a cow, raise the cow, and how much stuff
Methane.
no one
Rabbit.
else-
Methane.
methane and releasing in the air and all that stuff. It's just healthier and better for the environment.
But then we have overpopulation of animals if no one's
But
eating
what if-
animals.
No,
well,
because
then
we- no, because we
then
found
God
the
put us in
reduction
charge.
rate.
Wait,
Henry,
What
stop.
the heck was
Rate
that?
of the animal like farms or whatever would go down and they get out of business and there would not be overpopulation of them. The only
You
people.
realize,
Yeah, but then a lot of
you
people.
realize that like wild cows are a thing.
Yeah, I know
they,
they
they live without people's help. Therefore,
yes,
not using
but
any
most of it
mechanical
is
advantage
from-
or anything.
Most of it is
Therefore,
from
not
What's going on?
I don't know. I've lost this
Cow bar.
conversation.
And also,
I don't
it's
know
a very good
Sounded
source
out
of
hard.
news.
Except for the debate that was Michael, be careful.
That's dangerous,
When
man.
you use therefore, you just gotta stop.
Thus, wherefore
I
too.
say,
Yeah, there you go.
therefore.
Anyway, vegans aside, remember we talked about it last year too, the electric car thing. Like electric cars are marketed as green, right? Get your electric car. Well, where does the electric car get its power from?
Really?
Wait a minute, where's the electric car get its power from?
Us do.
From, guys, the electric car is going to get its power from electricity, and in most places, that's fossil fuels. So you're still burning the coal. You're still, depleting the environment of coal. Now I have, let me read this for you. So I put together like a little story for the juniors that kind of helped explain transfer of energy from one type to another. Whoops, wrong time. Is the wrong one? Here we go. So here you go. So you think about a waterfall. The water at the top has potential energy. As it falls, it becomes kinetic energy. So the miller who lives downstream from the waterfall, you have to imagine there's a miller. You know what a miller is, right?
Someone that mills.
Yeah, someone that mills. Very good. Downstream from the waterfall takes advantage of this now fast flowing water to build a water wheel. Everybody knows what a water wheel is, right?
Yes.
Yeah,
The
big
wheel of
thing,
water.
spins when the water hits it, right? All right. So he uses a series of gears and mechanisms to transmit the water's energy to a millstone where he grinds wheat. You know what a millstone looks like? It's usually it's a big round rock, typically, and it's a rock that's hewn into like a disc shape, but it's a thick disc like this, almost like a giant sweet tart, right? Massive, or Smartie, giant Smartie. And it usually has striations carved into it. Sometimes they're like kind of crisscross hash marks. And so that gets turned against another stone and the wheat's in between. So as the stones grind on each other, the wheat gets ground into flour, okay? So he transmits the water's energy to a millstone where he grinds wheat. So where did the initial potential energy come from?
Potential energy?
Mhm.
What?
Yep. The initial.
When water was first made.
Well, so he's using kinetic energy, right? From the moving water. Why is the water moving?
Because it's gravity.
Okay, so it was at the top of a waterfall. So it had gravitational potential energy at the top of a waterfall, right? All right, how did it get to the top of the waterfall?
Rain.
Rain.
Precipitation.
Okay,
Water
good.
cycle.
All right, so how did the water fall? Why was the water fall? Why did it fall as rain? Gravity, because it condensed up there, right? And it got heavy, got a lot of mass, condensed together, and then fell, correct? So now you got gravitational energy kind of twice in a row. Well, but what happened to get the water up in the cloud?
Evaporation.
Which is what kind of energy?
Good energy.
Solar.
Thermal. All right. So, and that continues and continues. So the energy is never lost in the system, right? It just keeps shifting from one type to another. So where does it go next once it's ground into wheat?
Down the
Cook that up, bread.
more.
So now it's stored, it's potential again, but it's chemical, right? Because we're gonna eat it.
Yeah.
That's the idea. And then whatever we do with that energy, like say you ate the bread and then you built a tower. You got your hammer and your nails and a bunch of wood, and you built a little wooden fire tower or hunting tower or whatever you want to build.
Towers.
And then you carry your gear up to the top. So now you've used the same energy that evaporated the water and came down as rain, and then came down the waterfall and went through the grinder and came out the grinder and went into you as chemical energy to now create gravitational potential energy to carry your gear up to the top of the tower. It's all the same. It just keeps shifting around.
So if I use the same energy as way back, even if it never ends.
So we know that the energy does not disappear
So how much?
at the
How
millstone.
much energy exists?
It's a great question.
Like if you
I
could
don't
put
know.
into pounds, I wonder.
And we know that it doesn't.
Put it to football
Yeah.
We know that it doesn't disappear because of the law of conservation of energy. According to the law of conservation of energy, energy cannot be created or destroyed. So the energy from the mill, from the water wheel, from the river, from the waterfall will always exist, but will continuously change form as it is transferred to do work, right? All right, so let's see. Y'all have turned in your homework pages, right?
What? Which one?
So
Oh,
I just
the,
want to see kind of
questions.
what answers can you give me anyway, even if they're turned in. So what are some ways to conserve energy?
Oh, well,
Use
don't
the machine.
Ivy?
Riding the bike instead of driving a car.
There you go.
Dang it, Ivy.
turning
Thanks for seeing
TVs
my
on, leave
answer.
the water
If
running
you
for
want
5 hours before you go.
Yep. Michael, you have one?
Turning off the lights.
Turn off the lights.
Yeah, just live in darkness.
Turn off any switches you're not using. Here's a smart one for you. This one will help you remember.
I totally misunderstood
turning on.
this question.
This will help you conserve energy and keep your house from catching fire. Did I tell you what my brother-in-law calls the little fans in the bathroom?
What?
Do you know what they're called? Okay, so
Let me see.
pardon the indelicate conversation, but the little fans in the bathroom, my brother-in-law, who's a fire captain, calls them fart fans. And I've never even heard that term. I was like, well, that's great. He says more house fires than he cares to count are caused by those. The reason is because,
Never
yeah,
goes on.
the reason is because the little motor in there isn't meant to run for a long, long, long time. It's not engineered that way, and it overheats and starts an electrical fire.
I'm kidding, right?
Inevitably, people will require use of the fart fan and then leave it and let it run. And he says more often than not, when they get a house fire, it's the fart fan. So conserve your energy, turn off your fart
I
fans,
just
and
kinda
don't
thought-
catch your house on fire.
I kind of thought it was like, you know, like when
Create
you're just
house
like,
fire.
if
Water
you're-
damage.
if you're gonna be
Water
sitting in the bathroom, like in front of the mirror, like doing your nails or something, like why not have a fan on? I thought it was like,
You will burn your house. Yeah. Well, that's what happens.
wow.
Apparently.
exactly
Yep.
sure
Not
what
getting my
that
nails
is.
in the bathroom.
The little fan in the bathroom.
That's
You know when you go in the
why I
bathroom, turn the fan on, it goes bzzz in the ceiling.
Oh, that.
That thing. See, now I have two different ones. Like my bathroom, I have one that's meant to go on with the shower, and then I have a separate one in the little water closet
Wait,
space. Those are the ones that catch
that's
fire.
a water closet.
Oh my
It's like
God.
when you just have a toilet
Oh my gosh.
behind a door.
It's a more,
Oh,
it's a
I got
your
one of
heater
those.
than a
What?
water closet.
Yeah.
I think I have not.
I don't think I
Awesome. So, what does the law of conservation of energy state? Who can put that into nice, easy words? Law of conservation of energy.
Conservation energy cannot be lost or transit.
Yeah.
Energy is
Not lost or what?
created nor-
Or created. Yeah, not created or destroyed. Only change forms. Okay, y'all. Good.
Not phone. He won't give it back. He needs.
These two. All right, so then how about wow, Miss Jackie has got to be sick.
I wonder
I didn't
what's
even hear her
happening
come
with
in.
that.
Did you? No. All right.
She's just not
Jackie.
there.
List
They're just
three
like, "Don't
types."
touch that." She's not even there.
I think they sacrificed Jackie. For something.
This was this was the best brownie point ever that Michael found because it was super ironic, but it was list three typos instead of list three types of fossil fuels.
Yeah.
Yeah.
Most amazing typo I've ever made, I think.
Yeah.
So meta.
So list three types of fossil fuels.
Well, I know one is in this room, but the two aren't are oil and natural gas. One of it is right there.
Okay, yeah. Oil, natural gas,
Oh, that's so funny.
And coal.
and coal, and
That's so
also nuclear, well, uranium, they said. Okay. So why are they called fossil fuels?
Because they're from fossils.
Ah,
Yes.
So here you go. Picture this one for me. What company did the king work for in in cars? What company did the king?
Dynaco.
Dynaco, right? And there's a little dinosaur, and it said Dynaco. Okay, why is there a dinosaur on it?
It's Dynaco.
Dynaco.
Because it's fossil fuel.
Oh my god. Wait, oh my god. I thought it was
Oh my
just a
God.
bus.
Caught that?
You just said it. I don't understand.
Look, man, my brain runs 3 seconds behind.
This for like an entire life.
There's also a real company. It's not around anymore, but sometimes you'll see the signs like in restaurants where they put up old signs. It's Sinclair.
Oh, yeah.
The one in downtown Cumming is Sinclair, and it's a green, like a Apatosaurus looking like thing.
Oh, that.
It's very similar to this, but
Is
it's
it the
real.
one
Are we gonna go to
tires?
Dynaco's from
No.
Dynaco's from cars?
What about
Yeah, but like
It is.
nobody from those Lego
Right,
City.
ignore
So Dynaco, there you go. Now you know why they did that. Isn't that cute? Oh, did you just think it was random dinosaurs that make gasoline? Come on,
That'd be pretty cool.
very creative. All right, and then so lastly, explain the conversion of energy in a swinging pendulum.
I know.
Yeah,
Something is wrong with the
yeah,
I have a question.
yeah. There is. Isn't that great?
Well,
Pendulum.
While we're talking about companies, is that like gas company with Lego City? Like is that like do they use fossil fuels?
What is it?
Probably.
What's it
Like,
called? Octane.
Octane,
Yeah. I don't know why it says octane. Does
It's
anybody know?
Red and green color.
Yeah.
Yeah, I don't know why it says that though. So who can explain the conversion of energy in a swinging pendulum? Picture like a clock pendulum. Who can explain that?
No,
It's got
I can't.
potential and kinetic.
Michael,
Yep.
you can
So
explain it?
it's, a clock pendulum or just
Any kind of pendulum, yeah.
well, if you bring it up, then you're using kinetic energy from your, and then you, right here, it has gravitational potential energy. You
Right,
let go, it has kinetic. And then it hits the other side, it stops for half a second. Then it has
right,
gravitational, it comes back down.
right,
Kinetic
perfect.
gravitation.
How about a bungee jumper, by the way? What goes on there?
Jump bungee.
Potential at the top,
He jumps up and then he
kinetic,
stops and there's
potential at the bottom, kinetic.
You get, yeah, and you get, when you get to the bottom, what happens when the bungee jumper gets all the way to the bottom? What does he have then? Elastic potential, because he shoots back up a ways, right?
I want to
Have you
do
seen the people who do that off the bridges?
Oh yeah, and they come like what?
Base jumpers and stuff, yeah.
My friend tried it, but she jumped wrong and almost broke her back.
Oh yeah. Wait, no, she's not supposed to jump it over.
I don't want to do that
She
ever.
fell wrong.
Ah.
How do you
She
fall
can't-
wrong?
You jump. You jump.
So I want to show you.
Aaron's asking the real questions.
I can put it up here because it's on my. I want to show you guys our friend. I think most of you saw our friend. Yep, we have a minute or two, so I want to show you our friend. So we have a new friend. When you come back,
Oh.
when you come back in January,
will he be here?
he will be here, and we are trying to come up with a name.
So far, the ones we
Esmeralda.
really like is like Wolfgang, because you can call him Wolfie because he's a tiny dog.
Mm.
And the other one's Waldo, because you say, "Where's Waldo?" And I like that one a lot.
You should do
Oh, oh,
We also like Walter.
You should do Walter. You should do Hagrid because he's so big.
Drew had it. What is it?
Hagrid because he's so big.
Hagrid. Nobody wants Harry Potter names, good name. But actually, Drew came up with a good one last night. He liked Brewer, which I thought. Yeah. So here, we can show you. Yeah, he wants Leonard. Nobody else wants
No, I
Leonard.
don't like that.
Waldo's okay. Waldo's okay.
Okay, let's see.
Oh, then he doesn't.
Oh, come on. Oh, well. All right. So here's our
Waldo?
friend.
That's good.
What is it? Could you die? No.
Is this live?
Isn't he itty? Oh gosh, of course. He's super cute back there. He is so sweet too. The itty, yeah. Where's the chocolate? Oh gosh, of course. Where is? I'll show you.
They're all shivering.
They were shivering because the fan. They were with their mama, and then the fan. There he is. There he is, people. This is our friend.
I could see Waldo.
He's gonna be less than 10 pounds probably because he's the runt. He's itty bitty. And I love you, little thing. Look at that. My hands. My tiny hands. Look at that.
Dude, my hands are smaller, bro.
Little tiny hands.
Oh, the ears are
He's in Drew's arms right there. So sweet. I like this one though, because he's looking at Jason like, you want me. You know you want me.
Look at Cole and your
Cole looks like a 2-year-old.
Hey!
You walk in the room.
But look.
We walk in the room, right? And there are 4 puppies in the litter, and then the lady there has has kids, obviously, but she has kids, and the kids come in, and they just pass out the dogs.
Yeah, they started handing them out to
Every one of
us.
has a puppy in our
Like
hand. We're just
freebies.
sitting
Here,
there,
take a dog.
probably so
And then we were passing them around everywhere.
There he is with his sisters.
Yeah,
He's the only boy.
He's the runt, too.
He's this one.
Aw, that's like Traveler.
Yep, that's the traveler. And that's the daddy. And that's the mommy.
That's a big one.
But who does he look like?
Me.
Me. I don't know about that. Oh, look, Cole, you got it. Look how tiny he is.
Oh, I
Ooh,
love
whispering.
I love you, dog.
What is it? I love this though. The little noises. Nice. Good job, Henry. There. So, anyway. So we're done for this.
Actually,
All right. Later, Lolly. So I'll tell you guys what our current list is. Maybe you have ideas.